Welcome everyone. Good morning, good afternoon, and good evening. We are very happy to welcome all of you. We have attendees from 3 different continents. And first of all, thank you very much for your time, registration, and joining us for this webinar. We hope you would be learning something new, and also towards the end of the webinar, you will be acquainted with our technology. So next slide. Yeah, so before we begin, some practical suggestions. You can see the orange arrow to hide the menu so that you can have complete screen in front of you. And then depending on whether you're joining from phone or laptop, you can select one of the options. You are unmuted by default. So if you have any specific questions, please type in questions to the bottom. And please do not forget to download 3 handouts. One of them is also today's presentation. And the last but not least, yes, the recording of today's webinar will be provided to all participants in coming days. Next slide. So who are we? We are Klaren International, based in Netherlands, which is also known as Holland. And my name is Amol Palve. I'm sales manager. I have more than 10 years of experience into techno commercial aspects. Together with me, I have Mr. Marco van Beek. He's CTO and also one of the managing director of Klaren International, with a mechanical engineering background and immense experience in the operational plants, and also PhD in fouling. He takes challenges and helps customers solve most complex problem in terms of fouling. So our core is engineering, design, and the commissioning of the plant. We are an engineering and technology company. We market, sell complete engineered products, and in order to do that, we also cooperate with network of specialists. Where we don't have competencies, we have partners and consultants available for particular industries. We have a team of process and mechanical engineers which are located in Netherlands office and also to India office. And the last thing, we don't manufacture it by ourselves. We try to manufacture it through our partners as well as the locally, so that we can have cost advantages. Next slide, please. Yeah, we are a member of Taproge Group, which is based in Germany, which is 100% family-owned company. Some of you might have already known about Taproge, which is well-known brand. They are known for its tube cleaning, cleaning technology, which is used based on their proprietary process engineering knowledge and also special sponge balls. They also offer advanced filtration solution for the water system, and more than 60 years they are market leaders, specifically to the power plants, and we are proud to say that they are a significant contributor to energy efficiency and saving 1 to 2% of carbon dioxide in thermal power plant applications. So if you'd like to know more about Taproge, you can visit their website or can also contact us, and we can introduce you to one of the local representatives. Next slide, Marco. So here you can see that we have reached almost in most of the countries through our local support from Taproge. So if you think that that face-to-face meeting or the plant meeting is required, you can always contact us, and our people are happy to see you, meet you, and discuss further. Actually, you can see with the red dots that our offices are based in Netherlands and India. So we are happy to discuss in case of any question you may have. Next slide, please. So the right side picture may be familiar to you, as well as from your customer side or your own plant. So these are the actual pictures which were shared by our customer before implementing our technology, and the current pictures really look completely different. As you know, the fouling is nothing but the unwanted deposition of solid or semi-solid material on the tube or the metal surfaces, which is a major cause of low heat transfer. And there are several effects like loss of energy, the production loss, or the reduced operation capacity. In order to overcome that and to run the plant smoothly, several customers, they go for oversizing, or the redundant equipment which add further capex to your system. And not to forget, there is regular maintenance and the cleaning, which is also adding a higher maintenance cost. And in order to do that, you generate several hazardous wastewater streams, which may or may not accepted environmentally and which need further treatment. And we might we also would like to discuss more about adjacent process conditions, but we would like to do that after one quick poll, just to see where are your key points and what you observe as a customer. So you can see the poll on your screen. You can answer or vote which is most applicable to you. The question is, which effects of fouling are most relevant to you? Is it loss of energy or production loss, oversizing or redundancy of equipment, higher maintenance cost, or hazardous waste stream from cleaning? So you can select one of them, and in few seconds I can answer. Yeah, we see 53% voted. Most of them are talking about loss of energy and the production loss. You can still answer. I see 65% voted. Yeah, still loss of energy and production loss is on top. Yeah, we can publish the results. So you can see here that 86% of audience is saying that they have observed loss of energy and the production loss, and the second important effect is higher maintenance cost. So this is absolutely true, and with the upcoming slides you would understand that how you can achieve up to zero fouling operation with Klaren self-cleaning technology. And for this, I would like to invite Mr. Marco van Beek on stage, virtual stage. And you can see that he has a nice background with our demo. So if one of you visit our Netherlands office in the future, you can see that how we can optimize or how this demo unit runs. So feel free to contact us to understand more about it. So Marco, over to you, and it would be great to understand more about our technology and references. Thank you.
Yeah, thank you, Amol, for the introduction of this webinar. So from my side, also welcome to all of you that have registered and now are participating in this webinar. We are very happy that today we can tell you more about what we do as a company and our solution, and also tell you about the recent accomplishments that we have done. To start my presentation, I would like to come back on the major problems with fouling in heat transfer equipment, because there's one that I also would like to highlight, and that is adjusted process conditions. And most of our customers, in fact, they also share with us that they have gotten used to the fouling problem. And in fact, that in their process, sometimes it is built in that they do the process differently than they would ideally want, because they have this huge an example is, for example, using direct heating instead of indirect heating. And what do I mean with that? Some people heat their process stream by injecting directly steam. And this is because a heat exchanger will always give them a lot of problems. So they directly heat the liquid by injecting steam, which of course then will condense in the liquid and give its heat. But this will dilute the process stream, which later will mean that you need to reconcentrate again. But it also means that all the steam that injected, of course, needs to be generated from fresh boiler feed water. So there's also a cost involved in just having this steam generated, not only for its heat, but also for the water content of this. A second example of this is, for example, in evaporator trains, where the temperature of the first stage is limited as not to enter into much fouling problems. Where for the optimum plant design, you would like to have a higher entrance temperature in the first effect, simply to make the equipment smaller. So we should not forget that sometimes our systems, or your systems, in fact, that's a better word, are designed just to get around the problem of fouling, but implicitly there's a lot of cost involved, and we should not forget that. And the example that I was talking about, for example, with the direct heating, that's something which is really well known in the mining industry. So what do we do? Well, in fact, our technology, the self-cleaning fluidized bed technology in vertical heat exchangers, mitigates this issue of fouling. And the way we do that is, in fact, by having an online and inline cleaning mechanism built into the functioning and continuously running heat exchanger. And as long as we clean, as we remove the fouling layer faster than that it can develop, the net result is that we have a clean heat exchanger. So this is very important, because in fact we do not change the process or the material or adding chemicals. No, we only focus on keeping the tube wall clean by removing the fouling layer. And now I come to a very important part of my presentation, that is, how does our technology work? And for this I will run the animation, which in some cases could mean that you see it a bit in staccato, so not a moving, but in frames. Yeah, sorry for that, but that sometimes has to do with the rate of data transfer. Luckily, in my screen, it's now running nicely, so I'll explain. In fact, the core of what we do is in the fact that we add cleaning particles to the liquid that normally gives the problem of fouling in the tubes. So we add cleaning particles to this liquid, and with the upward flow, so we do talk about a vertical shell and tube heat exchanger, it's essential for our technology. With the upward flow, we fluidize the particles in the tubes. So we fluidize those particles. What does that mean? Well, that means that they move in this liquid, but they move in a chaotic way. And that's also what you see in the circle on the left. They move in a chaotic way, and that means that they will impact each other. But more important, they will also impact the tube wall. And by these very small impacts, in fact, we create a light scoring action, a light cleaning action that continuously will wipe away any layer that wants to develop. This is essential because in the beginning, these layers are not strong. They are thin and they are fragile. And that's why we can remove them easily. This also means that we are not always capable to remove thick layers that are already present. Now, it could well be that that's not the case. So we can remove it, but it should be from the beginning. It should be directly from the start of the operation. So we fluidize those particles in the tubes. They give the scoring action. And at the end of the tube, so that's at the top, of course, we need to separate the particles from the liquid because the liquid needs to go to the next step in the process. So that can be after the heat is recovered, or for an evaporator, it can go to the vapor liquid separator, or for when you want to recover energy from surface water. You take out the energy and then the water will go back to the river or the sea. So before the process liquid is turned to the next step, we take out the particles in that bigger vessel on the right, which is called the particle separator. We have different arrangements for the particle separator, but in this moment we see that one of a very good functioning system is the one using gravity separation, where we separate the particles from the liquid, and the particles will go down and into this, what we call the downcomer. So this is that smaller tube on the right side, which returns, in fact, the particles back to the inlet channel, where we feed the particles, as already said, to this fouling liquid. This is important to mention because in the inlet channel, we have our patented distribution system, which in fact means that we know how to design it in such a way that we have a uniform distribution of particles over all the tubes. And this is, of course, very, very important because if you have a large bundle, which is maybe 1 meter in diameter with more than 500 tubes, of course, you want that every tube remains clean. So we need to make sure that we have a uniform distribution of particles in the system. Another thing to mention is that, of course, we want to control how much particles we feed into the system. And this is why we take a small side stream from the main process. This is what we call the control flow. And by changing the amount of control flow, we can in fact change the amount of particles that are pushed into the system. This is also the way we can stop the system at the moment that you want to stop the plant. So this is a very important phenomenon. So our technology, the fluidized bed technology, the scoring actions of particles in the tube, that's of course the main effect that we want to accomplish. But the second effect that we also should mention is that those particles have a very positive impact on heat transfer. They will increase the local heat transfer coefficients by a factor of 4 to 5. So that is also very positive because we want to have a good heat transfer in the unit, also to keep the size, of course, limited. But then it's also important that I mention one thing, because I say in heat transfer increases, but then we should compare apples to apples. And what do I mean with that? You look at the proper design of a vertical shell and tube heat exchanger, or any shell and tube heat exchanger, in fact, then in most cases, the tube velocity should well be above 2 meters per second if you have an application that is fouling. So a velocity of above 2 meters per second. In our technology, we cannot use this high velocity because that would create erosion of the tube wall, and that is in effect we don't want. And the question we always get in any presentation or webinar is, do my tubes erode? Does the wall thickness of the tube go down? Well, we can ensure you that's not the case because it's a light scoring action. That has to do also with the tube velocity that we have. This tube velocity is well below 1 meter per second. So if you then compare our heat transfer coefficient at lower velocities, but with the fluidized bed, against higher velocities, we are at a comparable level. So in fact, the effect of the particles makes sure that we compensate for the effect that we have a lower heat transfer. We have a lower heat transfer because in average, we have a very good heat transfer coefficient, but with a main benefit that this heat transfer coefficient over time remains constant. So that's already two effects discussed about, let's say, the action of the particles. A third effect, and that is also very relevant to mention, especially when you talk about high viscous oils or you talk about high viscous slurries, is that those particles can create a shear thinning effect. And what does that mean? They create a local shear in the liquid. And because a high viscous material, in many cases, is the viscosity can be influenced by the shear, what they call shear thinning, these particles will effectively do the same. And we have sometimes seen that the local viscosities go down by a factor of 10. And that will give a second boost in heat transfer, but it will also tremendously reduce your pumping power required. So this is really what we see as an upcoming application that we are working on together with some of our clients to get this, in fact, to a very perfectly functioning system. So three main effects of the particles: they clean, they increase heat transfer, and they can reduce viscosity when you have a high viscosity liquid in the system. This slide is very important. So if there are any questions, I most likely will come back to this slide because it really shows the core of our technology. I will go now to the next slide. In our system, we can use different type of cleaning particles. In this case, we show the most likely ones, which is a stainless steel particle or a ceramic particle. There are also other options, but it's not so likely that or where we do not use them that often. But you could also think about glass particles. Chopped metal wire is chosen because spherical stainless steel particles are not available or become too expensive. So we use a chopped metal wire, which has rounded edges to reduce the erosion that they will generate. Erosion, by the way, not in the tubes, but it could be in some other equipment. Or we can use the ceramic spherical particles. There is a difference in density there's a difference in the way they fluidize. So this is, let's say, based on our experience that we can find what is the best solution for your case. To tell you a bit about sizes, this will depend a bit on the tube size that we will select. And as you know, a tube size directly will relate also how long the heat exchanger will become. But typically, you have to think about sizes between 1.5 and 4 millimeter. Another very important aspect in the particles is how much volume percentage do they take in the tube. Volume percentage is nothing more or less than how many particles are there per unit of volume. That's of course a double up, but what I mean with that is it will depend on how much particle activity I have, and how much particle activity we have will determine how much removal we generate. And this is very important to mention again, because at the end, what we need to tune in our system is that we remove the layer faster than it can develop. So rate of removal should be larger than the rate of precipitation, if you talk about crystallization, or the rate of deposition of particles. That's a different mechanism. And we can tune that in our system by looking at the particles, which density, which size, but also what is the volume fraction of particles in the tubes. So in some cases, we need to adjust that a little bit. If we still see that there's some light fouling, we can increase the volume fraction of particles in the tubes, and the fouling will again disappear. This is also one of the reasons that we sometimes need a test. Because if your fouling problem is really specific and we do not have it in our experience portfolio, we might say, okay, let's first do a test. So in some cases, we see that we first do a single tube test to really prove our non-zero or our non-fouling performance. Then coming to the advantages. I will not repeat where my colleague Amol started with explaining again what are the disadvantages of fouling, because of course if you solve it, then the disadvantages disappear. So you will have the opposite of everything that was mentioned in the first slide. But I do want to stress the following, is that also in terms of pumping power, we can gain a lot. Because as I said, when I explained our technology, our system works at reduced velocities. That means that we, in most cases, require a shorter tube. And the combination of a lower velocity, for example, pump power goes with the square of the velocity, a lower velocity will reduce the pressure drop. But the pressure drop also goes proportionally to the tube length. So in fact, that goes hand in hand, and you see a very substantial reduction in the required pumping power. That can really be a factor of 4 to 6. And pumping power, of course, is energy, and everyone is looking for energy savings. So lower pumping power requirement is a very important additional benefit of the technology, of course, in combination with improving your energy efficiency and the availability and your production capacity. Then going to the applications of our technology. When you look at the applications, then in fact there are numerous. And if you look at the wide range of application that has been done in the past, it is indeed a wide variation. Areas we have more experience than in other areas, but what we can say is that if you look at the heat exchangers that have crystallization problems or polymerization or problems with particulate fouling, we have seen them and we have experience with them. Reboilers in the chemical industry, so where you have a forced circulation in the roof, because it's for our system, of course, that there is a constant flow. So thermal siphon is a lot more complicated, but with a forced circulation reboiler, we have experience also with sticky liquids. If you talk about heat exchangers for the white water and black liquor in the pulp and paper industry. In the first slide, you have seen one of the pictures showing a spiral heat exchanger, which had this clogging of solids. This is what we have worked on in the past as well, and we have experience with that. Heat exchangers for thermal desalination. So when you talk about brackish waters with brine, that's quite a common application for us. Every water that has salts that based on their solubility profile will tend to crystallize at lower temperatures or oppositely at higher temperatures. That depends on the salt. Will normally give a crystalline layer on your heat exchanger wall. These are applications that we are familiar with. One thing which is also good to mention, but we do not yet have a full-scale system, but that is crude oil preheaters. Here you could really gain huge amounts of energy. But our limit is that normally in refineries, these are horizontal heat exchangers, which would not fit with our vertical ones. But if a refiner, we would say, we would like to go and take the step and go to a vertical one, we are sure we can keep it clean because we have done a test in the past. Also, applications in recovering heat from geothermal brines. Working with the more viscous, already mentioned earlier, high viscous and high density slurries in the mining industry, making it possible to go to indirect heating. Direct seawater coolers. Doesn't happen that much, but we have experience. At this moment, an area where we do a lot of projects is in the evaporators for wastewater treatment, especially in countries like India, China. You see that more and more focus is on proper wastewater treatment to get to solutions to recover the chemicals, to recover the water. So a very important area of concern. The last application that I would like to mention is ice slurry. Then you think ice slurry, fouling, what does this have to do with one another? Well, the formation of ice, in fact, will give you an ice layer on your tube wall, and that has the same insulating effect as a fouling layer in the other application. So the formation of ice will reduce the performance of your heat exchanger. And where can you see the formation of ice? For example, in the recovery of heat from surface waters, or in the generation of ice slurry for HVAC systems. But we also have an application running where the client is working on the CO2 capture of flue gas, and they do this by dissolving the CO2 in an organic liquid. And to recover the CO2, they cool it, and then they have ice formation. So this is still also good to keep in mind how broad the technology can go. Well, then to show you some examples of our self-cleaning system in the real industry. The first one, I will talk about that a little more later, is a Revamp of a forced circulation evaporator for wastewater of a dye producer. The second one is in fact a reboiler application. I mentioned this specifically because it is in the chemical industry, and we were dealing with but with a sticky liquid, and still there the system was able to perform and keep the cleanings or reduce the number of cleanings in fact to 0. So initially they had more than a cleaning per week, and we could reduce it to 0. This unit in fact is already in operation for a very long time with a very good performance. The one on the right is in fact a more recent application. That was heating of the zinc phosphate solution. This was in the industry where they coat metal parts. They coat metal parts in a zinc phosphate bath, and of course, every time putting in this metal components reduces the temperature of the liquid, and they need a heater to continuously heat the liquid in this coating bath. That's why they installed the heat exchanger with our system to prevent the zinc phosphate of coating the heat exchanger, giving fouling to the heat exchanger. And we had a very good performance there. In the next slide, in this slide, you see the fourth example of our system. And this is an application in Japan. And also we've put it in because this unit is now also in operation for more than 19 years. And why is this relevant? This is relevant because of the following, because this plant was an evaporator for a liquid coming from the manufacturing of soju, so an alcoholic liquor. But tubes in the evaporator were from titanium with a wall thickness of only 1.2 mm. So if you put that between your fingers and you see how little 1.2 mm is, you can understand that if this heat exchanger lasted for more than 14 years before they replaced it, and not because it was leaked, but just of preventive maintenance action, that there cannot be erosion, because otherwise it will not last for years. So this is really a clear proof that the fluidized bed will not erode the tube wall, and that the lifetime of the heat exchanger bundle is in fact like a normal shell and tube heat exchanger. And in fact, I can even make it better, because normally if you use high pressure water jetting for your cleaning, this will give more erosion to the tube than our system does. So very important to emphasize. The last one that I want to show you is a wastewater treatment plant for the same producer of dyes in India that I spoke about in the previous slide. This is new build plants. So based on the first project we did with this client, we got quite some repeat orders. And to make them a very compact plant, we designed a 4-stage MEE plant with 2 stages that have self-cleaning. And in this plant, they treat 16 cube per hour of wastewater that contains both organic and inorganic substances. And in fact, the organic is a real driver for fouling in their case, because it gives problems with coking issues. We have now commissioned 3 of those evaporator plants. They are in operation since the second quarter of this year, with so far positive results. But of course, we were always looking to gain more experience. But this is a really nice example of how the customer got convinced by the first project and then awarded us with a lot of repeat work. So going in a little bit more detail about one case, and this is a revamp or a retrofit of an existing system, because I did not speak about that yet, but it's not always required that we make a new build system. In some cases, we can reuse the existing equipment, like the tube bundle, where of course most of the we can reuse this tube bundle and change it, adapt it with adding some parts, so that at the end we can convert it into the self-cleaning system. And this is also what we have done for this case, for the first stage of this multi-effect evaporator plant. We had chosen this stage because it showed the most of the fouling in the plant. Effect 2 to 4, in fact, also had fouling, but to a lesser extent. And this fouling issue was reducing the evaporation rate, which you also see on the picture on the right, between a capacity of 4.5, 100% to less than 50% of its normal capacity. And this is what we really see in a lot of more cases. In fact, you have said it in the poll, this is your #1 problem: reduced energy recovery or reduced production capacity. So this was the case for that plant. And they said most of our problems is in the first effect, so let's start with changing this effect into self-cleaning. And to do this, we have changed their multi-pass arrangement. So it was a 3-pass bundle, meaning the flow would go up, go down, and then go up again before it entered the vapor liquid separator. And we have changed it into a single pass, using all the tubes for the upward flow. And that was very nice coincidence, because we reduced the velocity. Then normally for the same flow, you would of course need more tubes, but since we got more tubes because we converted all the passes to upward, this directly fitted with one another. So without too much change in the process conditions, we could do this revamp. We have added the particle separator, which you see here in the middle, the down comma line with the control, with the down comma line with the feed of particles into the inlet channel, the channel mounted underneath the heat exchanger bundle. For this arrangement, we had to lift the vapor liquid separator a bit. That is not always required, and we have now versions where we do not no longer need to lift the VLS. But those were the changes that we did for this plant, and it was taken into operation in 2018. with some really very positive results. And you can see that in the same picture we're showing the evaporation capacity. This is actual plant data. The actual plant data is shown with the blue triangles and the red triangles. Blue is before the revamp and red is after. And you see that after the revamp for a longer period, and we now even have more data, the evaporation rate remained constant. And this was also a bit to the surprise of ourselves and of the customer, because we did not change effect 2, 3, and 4. But we even have seen that the fouling in those effects has reduced. It did not fully go away, but because of this very good heat transfer of effect number 1, it requires less, what we call LMTD, less driving force than the other effects, so that the other effects longer have their overcapacity, so they can maintain their evaporation capacity for a longer period. That means also that, in fact, if we would have entered more steam, we could even reach with the same plant more evaporation capacity. So this was a very positive result, and in fact, which I told you earlier, led to some follow-up orders from the same clients. A second case, again becoming more interesting in the recent momentum that we are in, is using geothermal brines for heating purposes. And geothermal brines, you have them in a wide variation of compositions. And I think in some cases the composition can be such that you do not need a self-cleaning heat exchanger, because there will always be an additional cost. But in some cases you for sure will need one. And especially when you talk about liquids with a higher amount of K, we have seen that really the fouling tendency can be really strong. And that's why this client also first did a test with our self-cleaning system. In fact, to cool the brine from 150 to 30 degrees. This pilot testing was successful, and after that they went for also the purchase of a commercial unit, which run also to their satisfaction, showing a constant heat transfer over time. Very relevant. Again, you have a liquid with salts. That's a repetition which we see in many projects. Aqueous liquids that have salts. Salts want to precipitate when they are concentrated or when they will cool down, and where our technology really can have a lot of added value. With this second case, I come to the part that was for questions and answers, and I hand over again to Amol.
Thank you very much, Marco. It was very interesting, and I hope our audience has learned something new. For sure, there will be an area of interest, and we see a couple of interesting questions, and I'll go through it one by one. And as I mentioned, that if you have more questions, please feel free to contact us through email or just contact your local person, and then we will be happy to answer more. Marco, we can take a couple of questions which are very important. The one question is which we typically observe, that since the particle move from cold end to hot end, will it affect the heat transfer?
Okay. In all cases, the particles, the fluidized bed, will improve heat transfer. And that does not depend on if it's hot or cold, because it has to do with the action of the particles that in fact reduce the thickness of the boundary layer. And that's a physical term, sorry for that, but this boundary layer, the thickness is reduced, and that's why heat transfer is in fact increased. So that will work for both for hot and cold conditions. This, of course, always also has to do with the average viscosity that the liquid inside the tubes has. So, of course, we will also see that if you have a higher viscous material, at the end we can achieve a lower heat transfer coefficient than if you have a very watery or less viscous material. That effect you will still see, but in all cases, adding the particles will give a boost to heat transfer. And it was nice, maybe a story to tell. One time we're doing a test, and for some reason an operator switched off the bed, and we saw that the duty of the heat exchanger changed from 30 kilowatts, so that's a single tube, imagine. It changed from 30 kilowatts to 10, simply because of this lower heat transfer coefficient. So switching the fluidized bed on again, boom, we were back at 30 kilowatt, showing in fact how impressive this effect of the fluidized bed is.
All right, thank you. The second question, which again we come across a similar question in the past, can we clean on shell side walls or outside tubes?
Can we clean the shell side? Is that the question?
Yeah, shell side or outside of tubes.
Yeah, I think that's what we then normally would call it, the shell side. Yeah, our technology is focused on cleaning the inside of the tubes. So the shell side, which can be the heat recovery part or can be the water, in fact, is not affected by the fluidized bed. So the most honest answer is no, we cannot clean the shell side. There's only one light but that I would like to make. In the past, we have worked on an application where, in fact, the fluidized bed was on the shell side. So in fact, the fluidized bed with the liquid was on the shell side, and inside the tubes, we had a hot gas, and in fact, a flue gas, but this could also be a hot natural gas that needs to be cooled. So there is a route where we can switch from tube side to shell side, but that's not our normal application, and it's also not an application that we can directly sell.
Yeah, thank you. We are getting a lot of questions. Let's see how much we can answer. The next one is kind of problem description. Our product is with melting point of 150 degrees Celsius. So I assume this product is maybe the foulant one. By 4 bar saturated steam, and the product which is on tube side falls within a short period of 1 week. Can our technology help them to solve their problem?
Yeah, well, if I were a salesperson, I would say yes, we can. But in this case, I would say I would love to learn more, because what we have said in the past, and this is in fact a strong belief that we have as the board of Klaren International have, is that we are only happy if at the end of the day a client is happy. So we will not run away from any project that has still an issue, maybe not even without technology, but in the plant. We will try and help to solve it. So that's also why for new cases that are delicate, is that we say, let us have a detailed discussion to really understand. And after that, we can say, yes, we can do it, or no, we cannot do it, or, well, we think we can, but let's do it. And I think this is one, especially that would fit in that category. So I would be very interested to learn more. I see options, but before we really can give an answer, we should know a little bit more.
The next question is, yeah, you know, the zero liquid discharge is getting very popular all over the world, especially in Asia. And the question is our technology suitable for multiple effect evaporators, effluent treatment for ZLD? I think I know the answer. The answer is yes, for sure, because we have several case studies already in the ZLD ME effluent treatment plant. So do you want to add something in there?
Yeah, you're absolutely right. What I would like to add to your answer is that, in fact, at this moment, we are working on a system where we push the concentrations already evaporated to the extent that we will have crystallization. And that means that the post-processing step we can do in a, let's say, a smarter way without using, or with using less energy. And because we also see options with activated thin film dryers or with spray dryers, which of course sometimes is necessary. So nothing to say about that. But if we can get to crystallization in the evaporator, and we're going in this case to push to 50% on concentration on weight basis, at the end we can recover the crystals directly with a centrifuge. and then the remaining liquid for the majority will be refed to the evaporator to reconcentrate again. So that we really go directly from concentration till solid formation.
All right.
So this is a project that we will be commissioning in the coming months.
Perfect. The interesting question from Geothermal brine customer, that do we have any experience in geothermal brine to recover lithium chloride?
We have experience in recovering heat from geothermal brines, but not specifically when it comes to recovering chemical components from geothermal brines. And right. That's the handicap that me as a person that I face is that I'm a mechanical engineer. I like to build equipment. I know a lot about the thermodynamics, but I know a bit less about the chemistry. So we really would need to look together with the customer at the chemistry involved to see how we can play with solubilities to get to solid formation where exactly these lithium compounds will also come out. But yeah, we with our partners can for sure work with that, but it's not something we have done before. So this would also require just to work together on this.
Yeah, there's a question, and one question, we have three questions, so I'll go one by one. I have three questions. So the first one, is there a limit to how small we can size the tube diameters?
The answer is twofold. In our standard applications, so where we directly feel comfortable, have experience, I would say the limit is that the tube size would be need to be roughly 20 millimeter, so 3/4 of an inch. Anything below that, I'm not saying that it cannot work. In fact, we have smaller demo installations that have a smaller size, but there we would really need to let's say it see and likely also test what we can do.
Yeah, and the sub question, how does it affect thermal calculation?
Can you repeat? How does
this affect thermal calculations?
The fluidized.
Can you hear me properly?
Yeah. Okay.
Yeah. So after the question of is there a limit to how small we can size the tube diameters, the follow-up question is how does this affect thermal calculations, and should we run at zero fouling to optimize sizing?
Yeah, you know that what I said already when I described the technology is that the rate of removal, our mechanism, is of course affected by the particle size. Why? You can imagine that the cleaning mechanism comes in fact from the impact of a cleaning particle with the wall. The impact, of course, the strength of the impact is determined by the kinetic energy of a particle. And as we all know from basic physics lesson, that the kinetic energy of any object will come partly from its mass. So the particle size will, of course, influence the mass and will influence the cleaning effect. So there for sure will be a limit. If we go below that it will be hard to remove a fouling layer that wants to develop. What we also see is in practice is that people do not like to go too thin tubes, especially because if a liquid has the tendency to already clog and plug, then you also want to have a bigger tube, because otherwise you directly will end up in plugging problems. So at this moment, we do not demand for using our technology in tube sizes below 15 mm.
Yeah. So there are certain general questions. Vertical heat exchanger mandatory, or are you open to accommodating for horizontal heat exchangers? I think the answer is already no.
Yeah, what I can, it is known. What I can add to it is we had multiple brainstorm sessions. What can we do to convert to horizontal? We know that there is an interest, but the problem is that gravity, one of the basic things in life, will tend to always get the particles at the bottom of the tube then. And you would have to do so many crazy things to get that moving, that for this moment, our conclusion is that it would create more problems than it solves. So that's why at this moment it's not within our portfolio.
There is one very interesting question is, what is the average ROI for a common Klaren project?
I'm not sure if there is an average ROI. That sounds maybe a bit stupid. What I mean with that is that in the new build case for the multi-effect evaporator plant, we have shown that even from the CapEx side, we were already very competitive, and you could even argue if we were more expensive. In most cases, our technology is more expensive than other systems. Now, yeah, it's for sure, because we have more equipment, we need the cleaning particles. So we are more we are more expensive in terms of square meters. But if you need a high oversizing, that could balance with the number of square meters that you need for a certain heat duty.
Yeah.
If you talk about a new build case, with a new build case where we compete against a situation with fouling, and I think typically the return of investment would be between 2 and 4 years. But yeah, that's really highly dependable on the client case. And yeah, of course, we are more than happy to really make a feasibility study just to find out what would be this return on investment, yeah, and then take it forward. Okay,
interesting one. The second is, of course, the one which we receive most of the time. Can our technology is possible to revamp the horizontal heat exchangers?
Yeah, that's also one in the area of frequently answered questions. Of course, relevant. So it is a relevant question. What we have seen in discussing and looking at all kinds of options is that when we go to a horizontal arrangement of tubes, we need to do so many tricks to get movement of particles in all areas of the tube and not only at the bottom side, that we create more problems than that we solve. So at this moment, we do not have a solution for the horizontal configuration. Still, there are quite, in most cases, options to go for a vertical arrangement and still apply our technology within the plant limitations.
All right. The next one is the product contaminated with worn out materials from cleaning particles?
Yeah, there are two aspects of that, because the contamination, if you have a heat exchanger, there will always be contamination with that fouling layer in your product, because it's inevitable. All heat exchangers will have some removal mechanism. You might not realize it, but even the shear of a fluid flow will give a certain removal. So part of the fouling and the fouling layers will always be present in the outlet going liquids. If you look at our technology, yes, it is the case that over time the particles will degrade a bit. Typically, you have to think about between 3 and 5 weight% per year. So of course this material needs to go somewhere, and you will find it in small solids in the outlet liquid. But the concentration will really be low. And if that would then be an issue for your application, there are also ways that we filter, and not with a filter, but that we can retrieve those solids from the liquid and remove them. We have some solutions for that, which are also very known to to the food industry where they are common practice. In that way, we can ensure that product quality is also not affected.
Yeah. All right. Again, the next interesting question, which we receive most of the time, that can this technology be applied to the shell side or plate and frame heat exchangers?
Yeah, I think around 4 years ago, we also were requested to look at the possibility to integrate our technology with a plate heat exchanger. At the end, the conclusion is this will be really hard because typically the distances between the plates of the plate heat exchanger are very small. So if you then need to create a proper fluidized bed, that will already be very hard. Recirculating that will never be possible. So at the end, we concluded that yeah, this is a bit too wild, and we did not see an option to integrate that. If you look at shell side applications of fouling, normally in industry it's chosen to have the liquid which has the most fouling issues, to have that on the
Marco,
tube.
there is some disturbance. There is some disturbances. Maybe you could switch off your video for a few minutes until you answer your question, because we could not hear you last 30 seconds.
Okay. Can you hear me now?
Yeah, better.
Okay. So talking about shell side fouling, of course, our system is active on the tube side, and that means that yeah, the shell side is not protected. What we see in most of the cases is that clients choose to have the most fouling problems indeed located at the tube side. This is also the most easily cleanable, and that the shell side is then the liquid with less fouling. Still, there can be applications where you will have fouling on both sides, and then of course our technology will not provide a solution for the shell side. We have worked on an application where the fluidized bed is covering the shell side, but that was because we wanted to cool a very hot gas which was on a high pressure, and then it's of course in terms of design preferred to have the gas at the tube side. So there we have designed a shell side fluidized bed heat exchanger, but that is not our common solution.
Yeah. All right. So we have next couple of minutes. I can take 2 more questions, I guess. How do you fully remove the fluidized bag grain particles from the channel fluid? Example, by electronic electrostatic precipitator, etc.
Yeah, if you talk about the efficiency of the particle separation, of course, what you would like to do is just put a sieve in so that you're sure that no particle could leave just because of the pore size. But yeah, then the sieve will also become the limiting factor for plugging issues. So we have seen that the gravity separator really gives a very good performance, and based on very extensive sieve work, we know that yeah, the safety margins in the separator are really good, and that even if the flow would go to almost twice, then still no particle can escape. So we're quite confident that there's no risk of carryover of particles towards the pump.
All right. The last question which we can take, how is your experience with respect to zero liquid discharge area?
Yeah, our experience is only starting. In the MEE, we already pushed the concentrations, but we are working now on a project with an MVR, where in a single stage we treat reject from reverse osmosis membranes, and we will push the concentrations there directly till we get crystallization, so that we in fact can directly use centrifuge to take out the solids. So we do not need to go to solutions with spray drying or ATFD, which normally take quite some energy, but we directly will use the evaporator to go to concentrations that give rise to crystallization and give crystals that can be separated then with a centrifuge. So then the combination of the evaporator becoming a crystallizer with a centrifuge is a direct ZLD. After the centrifuge, some of the liquid is then fed back to the evaporator, so they have a continuously cycle. And there's only a small purge which is then still left that contains the impurities that do not want to crystallize.
All right, thank you. I think we covered most of the questions in time. There are a couple of questions, but we already answered it during your presentation, so I would not repeat it. So, and since we talk about ZLD, I think it's worth to have our second poll, because we see that now we have audience from Asia, Europe, and also North America, and we know that ZLD is getting very popular in Asia, so we can have second poll and understand what our audience think about ZLD system coming to the market. So let's raise the second poll and see how much answers we receive and what audience think about it. So the question you can see on your screen: does your or your client industry need zero liquid discharge or ZLD system for effective wastewater management? So you can vote which is most applicable to you. Yeah, 33% voted, 40%, 53%. So let's see a few more votes. If you're using more than one screen, maybe question is pop up on second screen, so you can have a look. So almost 70% voted, and we see that yes is leading. So I think we can already show it on the screen, and you can see that the output is yes. Most of the people think that yes, their industry need zero liquid discharge system, yes, because the population is growing, there's water scarcity, and the is getting very popular. And 36% I see they are saying I'm not sure. So maybe if you have more question about it, you can come to us, and we can introduce you to right people, because there are also some of the partners or consultant we have who are active into system integration. So yeah, that's it, and we can go to next slide quickly. I have one announcement to be made, and then we can wrap up with the webinar. So there are several clients which come to us and they say, yes, we understand the Klaren International technology, we understand what you have done, your technology, the details about your technology. Why don't you deep dive and share some of the operational experiences? And we would like to take the opportunity in the month of November. You can see on the left side, 17th of November, same time, we are arranging second webinar where we will deep dive into some of the actual operational experiences. One of them Mark already mentioned, which is newly built MEE with our self-cleaning technology from Asia. So this will be the first subject. Second is the world first the vapor decompression plus self-cleaning technology will also be discussed in detail. And the third one is from a European customer, where heating and cooling system will be discussed from edible oil plant. So I will make sure that you will receive a registration of upcoming webinar. Feel free to register, and if you have more questions, again, you can contact us at info@klaren.bv. And additionally, to the right side, you can see that we are also presenting and exhibiting in Netherlands itself, our home country. And then the conference is scheduled on 30th of November and 1st of December. So we'll be there for 2 days. If some of you are joining, please feel free to visit us. We can have open face-to-face discussion, and we'll be able to share more about our technology, more about our information. Yeah, if possible, you are also able to visit our office and have some demo in our demo unit, which is behind Marco. So feel free, and we can wrap up our webinar. And you can see on the next slide that our office is located in Netherlands, and let's connect it through email or social medias. And yeah, have a nice evening, have a nice day, and stay safe. We look forward to talking to you more about your problems or fouling issues and how to achieve up to zero fouling operation. Thank you very much.